Picture this. You're walking onto a massive factory floor. It's loud, it's incredibly busy, and it's generating literally terabytes of invisible data every single day. But, something is fundamentally different here. Before a critical motor even thinks about breaking down, a silent system has already predicted the failure and scheduled a fix. Meanwhile, right above you, overhead cameras are spotting microscopic product defects in a fraction of a second, way, way faster than any human eye ever could. And behind the scenes, energy consumption is being automatically analyzed and optimized to just slash costs.
Now, I know what you're thinking. That sounds a bit like science fiction, right? But what if your factory's data could literally predict the future, today? Well, let's dive into this, because this is no longer just some futuristic fantasy. Artificial intelligence is completely transforming the modern manufacturing industry as we speak. We're talking about a massive shift from a reactive environment, where we basically just wait around for things to break, to an incredibly proactive and predictive ecosystem. So welcome to this explainer on artificial intelligence in manufacturing.
Okay, so here's our roadmap for today. We'll start with smart manufacturing, then break down the core components and workflow. After that, we'll look at some real-world apps, dive into a smart pumping system case study, weigh the benefits and challenges, and finally, look at DEVI solutions. Let's get right into it.
Section 1. AI in smart manufacturing. Let's quickly establish what we actually mean when we talk about AI in this specific environment.
So, the absolute key here is understanding this definition. AI in manufacturing isn't just about hoarding data. It's about taking those massive, overwhelming amounts of machine data, sensor data, quality data, and energy data, and actually doing something smart with it. Instead of just recording the information, the AI analyzes it to find hidden patterns. Think about a simple motor, right? It constantly generates data on temperature, vibration, current, voltage, the whole shebang. AI learns what the normal state of that specific motor looks like. The very second, and I mean the literal second, an abnormal pattern starts to emerge, the AI detects the problem and makes an intelligent decision, like firing off an autonomous warning.
And this comparison right here perfectly illustrates why AI is such a total game changer. In a traditional system, it's purely reactive. A sensor talks to a PLC, which then triggers a basic control on the machine. Done. But in an AI-enabled smart manufacturing setup, the workflow totally expands. The sensor data flows through the PLC, gets sent via the Industrial Internet of Things, or IIoT, straight up to the AI. The AI doesn't just sit there and monitor. It creates a prediction, leading to a smart decision, and finally, a proactive action. We're moving from just controlling our machines to actually understanding them. Section 2. Components and workflow. Now, let's actually build the architecture of a smart factory, component by component, kind of like reading a digital blueprint. It's honestly fascinating how all these different technologies play together. At the base, we've got our sensors, capturing the physical reality, so temperature, vibration, pressure. Then we have the PLC, the programmable logic controller. Now, really important note here, AI does not replace the PLC. The PLC provides the real-time machine control. It's the hands. HMI, or human-machine interfaces, and SCADA let human operators visualize everything. But to get smart, we need the IIoT gateway to grab that factory floor data and push it into a database or the cloud. Up there, our final component, the AI model, acts as the brain, recognizing patterns and finding anomalies.
Once you have those components in place, they follow a pretty slick four-step workflow. First up, data collection continuously harvests raw information from the factory floor. Step 2 is data processing, which organizes that massive, chaotic flow of numbers. Then step 3 is where the real magic happens, AI analysis. The machine learning models are trained on this data to recognize patterns and make predictions. Finally, step 4 is alert and action. The AI makes an intelligent decision based on what it found and triggers an automated action or flags human operators on a dashboard.
Section 3. Real-world applications. Time to take our blueprint and see how it actually operates on a live factory floor today. So one of the absolute biggest use cases is predictive maintenance. Imagine a machine operating perfectly normally, but over time, wear and tear start to happen, and an abnormal pattern emerges. Maybe just an ever-so-slight increase in vibration or temperature. Way before it ever triggers a standard alarm, the AI detects this anomaly by comparing it against historical data. A warning is instantly sent, allowing the team to perform preventative maintenance. This is huge because it completely eliminates unexpected machine breakdowns and devastating production downtime.
Another really cool application is AI-based quality inspection. Picture a super fast-moving production line. As a product zips by, high-speed cameras capture incredibly detailed images. But instead of a tired human trying to spot errors, an AI vision system processes the image instantly. It's explicitly trained to look for scratches, cracks, wrong sizes, or missing components. The very millisecond a defect is detected, the system triggers an automatic rejection. It is exponentially faster and far more accurate than human eyes, which drastically improves overall product quality.
And, the applications definitely don't stop there. Take energy monitoring. AI analyzes data from pumps, compressors, and HVAC systems to pinpoint energy wastage and optimize peak loads, saving facilities massive amounts of money. Then there's production optimization, where AI looks at machine utilization and cycle times to streamline the entire manufacturing process. And of course, AI robotics. We are rapidly moving away from simple pre-programmed robots to intelligent systems capable of autonomous material handling, smart sorting, and dynamic machine vision assembly. It's wild stuff.
Section 4. The Smart Pumping System. Let's lock all this theory in by looking at one cohesive, highly practical industrial case study. Imagine a massive, critical pumping system in a facility. To make it smart, we have to constantly harvest real-time data from it. We're talking motor current, motor temperature, pump pressure, flow rate, vibration, and RPM. This is the raw material the AI absolutely needs to do its job.
All right, now watch how this all turns into an intelligent action. The sensors feed all those metrics right into the PLC. The PLC then sends this data to the IIoT gateway, pushing it up to the database. And this is where the AI model goes to work. Let's say the AI detects a really unusual pressure pattern combined with a slight vibration anomaly. The AI predicts an impending failure, makes an intelligent decision, and triggers an alert directly on the maintenance team's SCADA dashboard. They swoop in, fix the issue during a planned window, and the machine's life is extended without a single minute of unplanned downtime.
Section 5. Benefits and challenges. The potential is obviously huge, but we need to have an honest talk about the real-world hurdles of actually implementing this.
On the plus side, the benefits are practically undeniable. We're talking massively reduced machine downtime, slashed maintenance costs, greatly increased energy efficiency, and much higher product quality. It even improves worker safety by predicting hazardous failures before they happen. But the challenges are just as real. You've got a heavy initial financial investment for one. There are also serious data privacy and cybersecurity concerns when you start connecting factory machines to the cloud. You need highly skilled engineers to maintain these models, and let's be real, integrating modern AI with older legacy machines can be a total headache. Plus, remember this, AI models rely entirely on the accuracy of your sensors. Bad data in means bad predictions out. So human supervision, still absolutely essential.
But if we look ahead, overcoming those hurdles is the exact key to unlocking the true future of manufacturing. We are racing toward fully realized smart factories and Industry 4.0. We're starting to see edge AI, where the artificial intelligence runs right on the machine itself rather than up in the cloud, speeding up response times immensely. We're even seeing digital twins, which are exact virtual replicas of physical factories used for simulation. The future factory isn't just a place with automated machines, it's an intelligent environment that inherently understands its own data, predicts its own problems, and makes autonomous decisions.
Section 6. DEVI Automation Solutions. Let's wrap up by talking about how facilities actually bring all this cutting-edge tech out of the cloud and onto the real factory floor. I really want you to take away this single powerful thought from our explainer today. Automation makes a factory run. AI makes that automation intelligent. It's no longer just about doing things automatically. It's about doing things brilliantly.
And if you're looking to actually integrate this kind of smart technology into your own operations, you absolutely need to know about DEVI Automation Solutions. Their expertise spans the entire architecture we broke down today, from industrial automation, PLCs, and SCADA, all the way to advanced AI, industrial IoT, and even smart agriculture and home automation. They basically act as the bridge between traditional manufacturing and the intelligent future. So for business inquiries and technical solutions, you can reach out to them directly at deviautomationsolutions@gmail.com.
Well, if you found this explainer helpful, go ahead and subscribe to the channel for more deep dives into industrial technology. At DEVI Automation Solutions, the goal is simple: smart technology, powerful solutions, better tomorrow. But I'm going to leave you with this one thought to chew on. If your factory's machines could talk to you right now, what are they trying to say? Thanks for joining us, and we'll see you on the next explainer.